Hello, everyone, and welcome back. Today, we have something truly fascinating to discuss, a cosmic mystery that's been unfolding right in our own solar system.
That's right. We're talking about our interstellar visitor, 3I/Atlas. If you've been following the news, you know this object has been puzzling astronomers for months. But now, thanks to the Hubble Space Telescope, we have a brand new image that might just crack the code.
It's a huge update. The image was taken on November 30, 2025. At that point, 3I/Atlas was about 286 million kilometers away from Earth.
And context is key here. This date is significant because it's exactly 1 month after the object made its closest approach to the Sun, known as perihelion. So we are seeing it as it travels back out into the dark.
Exactly. And the picture Hubble sent back isn't just a blurry dot. It reveals a very distinct, almost poetic shape. It looks like a glowing teardrop.
A teardrop? That's a very specific description. What creates that shape?
Well, the image shows a halo of light with a radius of about 40,000 kilometers. But here is the weird part. There is an extension, a tail, stretching out about 60,000 kilometers. But unlike a normal comet tail that blows away from the sun due to solar wind, this one is pointing towards the sun.
Wait, pointing towards the Sun? That's what astronomers call an anti-tail, right? That's remarkably rare. Usually, the pressure from sunlight pushes dust and gas away. So why is this tail reaching toward the star?
That is the million-dollar question. And actually, this isn't the first time we've seen it. Hubble saw this same sunward extension back on July 21, 2025, when 3I/Atlas was still approaching the sun.
So the feature is consistent. It was there before it got close to the Sun, and it's there now that it's leaving.
Right. And there is a fascinating explanation for this. A recent research paper has proposed a hypothesis that connects all the dots perfectly. The idea is that the teardrop shape isn't just gas or fine dust.
If it's not just dust, what is it?
The paper suggests that the teardrop is actually a swarm, a massive collection of macroscopic, non-volatile objects. Think of them as larger chunks of material rather than just fine mist.
Okay, I'm picturing a swarm of debris, but why does that create a tail pointing at the Sun?
This requires a little bit of orbital mechanics, but let's simplify it. We know that 3I/Atlas exhibits non-gravitational acceleration.
Just to make sure everyone is on the same page, that means something other than gravity is pushing it, right? Like a rocket effect.
Exactly. Usually, this happens when ice on a comet heats up and shoots out jets of gas, pushing the object like a thruster. Now, imagine 3I/Atlas gets this push away from the sun, but the swarm of objects that separated from it, they don't get that push.
Ah, I see where you're going with this. The main body speeds up and moves further out, but the heavy debris gets left behind.
Precisely. Because the debris doesn't have that extra propulsion, it stays a bit closer to the sun than the main body.
So, from our perspective, that trail of debris looks like it's reaching out toward the Sun simply because the main object is running away from it faster.
You nailed it. And the math is incredibly precise. The research paper predicted that by November 30, if this swarm theory was correct, the debris should be closer to the sun by about 60,000 kilometers.
And that matches the Hubble image?
Exactly. The anti-tail extension in the new image is exactly 60,000 kilometers. The prediction and the observation are in perfect agreement.
That is satisfying science right there. When the math on the page matches the picture in the telescope, you know you're onto something. So what's next? Do we know what this stuff is made of?
Not quite yet. We are currently waiting for the full release of the Hubble data set, which includes ultraviolet spectroscopy.
That'll be the chemical fingerprint.
Exactly. That data will tell us the composition of the gas plume surrounding 3I/Atlas. Once we have that, we can confirm if the chemistry matches the physics we're seeing.
I also want to give a quick shout out to the amateur astronomer community. While Hubble is doing the heavy lifting on the fine details, amateurs are capturing these magnificent wide-angle shots showing the structure extending out millions of kilometers.
It really is a group effort to understand the universe. But before we wrap up, there is something else we need to touch on. It's a bit of an addendum to this story, but it's crucial for everyone listening.
Right. We're talking about the quality of information. In an era where AI can generate almost anything, we're facing a new challenge, the AI nemesis of scientific truth.
It sounds like science fiction, but it's real. Imagine scrolling through your feed and seeing a video of a famous scientist, someone you trust, explaining 3I/Atlas. They look real, they sound exactly like themselves.
But the words they are speaking are totally false. They could be spreading counterfactual information, claiming 3I/Atlas is something it isn't, or denying the data we just discussed.
It raises a scary question. How does the public know who to believe? When the simulation is as good as the reality, verified data like these Hubble images and peer-reviewed papers become our only anchor.
It's a good reminder to always check your sources. If you see a sensational claim, look for the paper, look for the raw data links, like the one we mentioned for the research on the teardrop shape.
Absolutely. The universe is mysterious enough without us inventing fake mysteries. For now, 3I/Atlas remains a fascinating, real visitor, dropping clues in the form of a golden teardrop as it sails back into the deep.
We'll keep you updated as soon as that spectroscopy data comes in. Thanks for listening and keep looking up.
See you next time.